Okay, part two. We're doing logarithms, this thing, and hopefully you all were able to work out the blacks. Now some of these are tricky, so let's get into it. Okay, fine. Log base 2 of 8. Okay, this one's not too bad. What color should I work on? I'll work in purple. Instead of the power of 10 to get me to 100 like it was up here. Yeah, stupid thing there. Let's go back into get this in type mode. The power of 2 to get me to 8, well, that'd be 3. Okay, that one's not bad. Now, could I map that thing? If I were to map that thing, what would it look like? Well, 2, the base of 2 to the third power should be equal to 8. And we know that to be true from our exponential unit we did a couple days ago. Okay, this one. Now, this one's a whole lot trickier. 2 to what power is 1 over 32? Well, it's hard to map this without having an x over here, but let's just say my answer is going to be x. And let's do the mapping thing we had just up above over there. So by looking at the map, I've got my logarithm function over here. Stupid mouse keeps turning into a point. Anyway. Right up here, when I'm doing the mapping, I want to say, remember, this b to the y power is x. So 2 to the x power equals 1 over 32. 2 to the x power equals 1 over 32. Now that looks a whole lot like the simple solving of exponentials we did a couple days ago, where we basically have to get these both to be the same power, and hopefully you can see, well, 1 over 32 is the same as 1/2 to the 5th, or 2 to the negative 5th. And therefore x would have to be equal to negative 5. So the answer on this one is negative 5. And there's a way to do logs in a calculator. It's hard for me to show you how. I would put it up on the screen. But in any case, if you 2 to the negative 5th, you do that on your calculator, you'll see you get 1 over 32. Okay, next one. Hopefully now we can say, okay, fine. Let me create a, actually I should create these as y, right? Because usually we're saying y equals log base something of x. It doesn't really matter. 1/3 to the y power equals 27. Okay, fine. So this would be 3 to the negative 1 is 1/3 to the y power equals 27. And so 3 to the negative y equals 3 cubed. And so in this case, y would be equal to negative 3. Okay. Log base b of b dx. Now, this one's interesting. B to what power is b to the x? Well, the answer, of course, is x. And the key on this one is a log of its exponential. Now, in this case, they cancel each other out. And that's an important point that we'll use in lots of solving. Log base b of b dx is simply x, because the log is an inverse function of the exponential. It cancels out the exponential, so you're left with x. And if you come back up here, and let's look at this one right here, and you can say, oh, so that's log base 10, and 1,000 is 10 cubed. And the log base 10 and the 10 power right here, the base, are going to cancel out, and we're left with 3. Oh, I can see how that works. Okay, very important point. Now, let's use that knowledge to solve one that looks really good. Think about another one. A. 10 raised to the log of 9.6. Now, don't forget, I am assuming there's a base 10 here, because I don't have to write that if it's not written, it's assumed to be base 10. But let's put this into words. 10, and I guess I'll put a box around it. 10 raised this whole black box here, 10 raised, and don't forget what this means right here. The log base 10 of 9.6 is the power of 10 that will get me to 9.6. So I'm going to raise 10 to the power of 10 that will give me to 9.6. And guess what? You're going to get to 9.6. And so I'll write those in words. In words, that raise 10 to the power of 10 that gets to 9.6, and the idea here is the exponent of a log also cancels out. So hopefully you can see how, I don't know, I'll put a pink box around both these guys. They're both different ways of showing the inverse function canceling out each other. The log of its exponent or the exponent of its log. In both cases, they cancel each other out, and that's what you get to. So let's try one. Let's do B. Raise this up. If I have log base 7 of 49 to the 2x, see if you can do that one. Hit pause. Go, try it out. Okay, I'll come back. Now, just like with exponents, we want to get the 7 to be the same as the base here. Is there a way to get 49? Of course, 49 is 7 squared. So I would say log base 7 of 7 squared. Now it's the same thing as 49 to the 2x, which of course is the same as log base 7 of 7 to the 4x. Well, guess what? Now I got the 7 and the 7 matching. The 7 is the base of the log, the 7 is the base of the exponent. Then I can say, fine, 4x is the answer. Cool. I don't know. Should we do a graph? I think that'll be, we'll do one graph, just in case you want that. Again, with videos, you can just cancel at any time. If I want to graph y equals log base 10 of x minus 2 plus 3. There. Good. I was able to scroll that down. And if I think about this, what kind of transformations might be involved here? It looks like this, a, h, and k. There's an a log base b of x minus h plus k, just like there always is. It looks like this is going to do a right 2. It looks like that's going to do an up 3. So what was our parent function? Let's go back up here and look. Remember how the parent function looks, the blue function is like my parent log function, and it looks a lot like the parent exponential function. Instead of a horizontal asymptote, it has a vertical asymptote at the axis. Instead of going through the point 0, 1, it goes to the point 1, 0. All right, let's draw that. I'll do it in, I would do it in blue, but I'll do it in red. So my parent log function looked kind of like that, right? And then if I take this thing, and if I move it right 2, won't I have an asymptote? Instead of being the vertical the y-axis, it'll actually be the line x equals 2 will be my vertical asymptote. Again, I'm doing this function right here. Okay. Now, how do I get points? This is tricky. What are easy numbers to take the log of? I ought to make a table of values here. My x and my y table. It's easy for me to take the log of what numbers? I want to take the log of 1. can easily take what is the log of 1? Now this is log base 10, that is. The log base 10 of 1, yeah, it was 0, wasn't it? What's the log base 10 of 10? Well, that's 1. So there's certain numbers I can take the log base 10 of very easily. Now, what does x have to be to get me a 1 inside of here? Well, make it a 3. Let's be smart with our points. If x was 3, 3 minus 2 will give me 1. Log base 10 of 1 is 0. 0 plus 3 is 3. So my graph should go through the point 3, 3. 3 would be like up here. Call that 3, call that 3. Okay, fine. What do I have to do to get a 10 inside of here? Well, x would have to be all the way at 12. Fine, I can make x 12. 12 minus 2 is 10. Log base 10 of 10 is 1. 1 plus 3 is 4. Okay, the point 12, 4 would be way out here somewhere. Call it 12, and 4 is not much above 3, so it's like there. And so I can say, interesting. That's not a very good graph, but let me make this point a little bit higher. I think it'd be a little bit higher. And so I'd end up having a vertical asymptote that goes like that. So lo and behold, that which seemed like an impossible graph to make, I have to get my calculator out, or Desmos have to do that. Nope, you don't. You just have to think a little bit like we always have. Okay, hope that helps. Later, guys.